I'll share my screen. Okay. Hi everyone. This is Bail here. Is my voice clear?
Yes, Bill, it's clear. Yeah, for me.
Okay, fine. Okay, let us start today on the AWS data engineering. What we are going to learn today is introduction to AWS data engineering, and we will focus on the basic, right? On architecture, on the data layers, and mainly on data lake. So we will focus on the basic things which are required for starting AWS data. So how the session is going to be, so we will always start with few concepts, few basic concepts, and we will get into technical concepts and we will go into technical implementations. So that is how session is going to be. So some concepts, more technical implementation, and also real use cases, and some use cases with examples, how to solve, and what complexity we had in the scenarios, in real world scenario. So I'm covering all this thing. Okay, that is how the classes will be. More on the working scenario and then the use case on that. That is how the classes will be. So let us start. So, like we know that analytics or machine learning A is used across different sectors. So it can be banking, it can be machine learning, it can be different sectors, right? Healthcare, manufacturing, energy, educations, insurance, transportations, communication, different sectors. So it is used in a startup, it is used in a bigger enterprise, it is used in the different company. So if you take startups, right? So they want to improve their customer, they want to increase the customer base. So they do analytics, they see customer usage, customer insights, so they do their analytics. Because if you see existing customers, they want to see how the sales is, how which product is selling good. So the analytics helps them to improve their each of their sector, each of their product unit and business group. Okay, so analytics used across different industries and different sectors for different use cases, and it's used in banking, healthcare, all the bigger sectors in bigger enterprise. Okay, so next is if you see for the 2025, the data which we have is around 200 billion, and which is going to gradually grow for next 10 years. The data is going to grow huge because of lot of use cases, right? So there are with the ML use cases, AI use cases, analytical use cases, and each company have larger user base, and larger applications. They are developing a lot of applications. So the data is going to go huge, and the need of data engineers are going to increase, because when the data are going to increase in the source systems, so they need to collect this data, they need to transform this data and store it in centralized place for analytics or machine learning. So there is always going to be need in the future also for data engineers. For next 10 years, the market is going to be trending for data engineers. Okay, this forecast analysis says that for next 10 years we see a big growth in the data sector, and there is a lot more need for big data engineers. Okay, next is for a business, the analytics or machine learning or AI are useful in different places, starting from customer, market segment, demand analysis, to like a business, or to implementation of chat support, everything. Analytics and data very important. Data plays a major role in all these places. So where it is mainly useful, let us see one by one. So starting from understanding the customer. So customer insight is understanding who is our customer, which product they are using, and what is their use cases. So understanding the customer, your analytics or your data helps you to understand the customer better. So by clickstream, by using the customer data, we are going to understand the customer better. And next is your data is going to help to understand the market intelligence. So it's going to understand what kind of supply and demand is there in the market. So which will be demanding for next quarter or next year. So the data is going to help you. And your data is going to help for supply chain. For example, uh, for enterprise, let us say they are manufacturing of cars or they are manufacturing like laptops or any manufacturing companies, right? So they need raw materials coming from different suppliers. So that suppliers, they need to understand if their suppliers are going to send the data, like send the raw materials on the correct date, or the materials will be delayed. So we need to understand that. So supply chain analytics is going to help you to understand more about suppliers. So like this, each analytics helps you to understand the different players, starting from customer, market, supply chain, suppliers. Like that, each data segment helps you to understand the different customers, market, supply chain information here. Other than that, recommendations, audience targeting, which is nothing but you understand based on the customer search, customer usage, you recommend them products. So recommendation is another use case. A data driven product or data driven application is another use case. Like different use cases to improve the business, right? Like starting from machine learning, like LLMs, right? Like LLMs, AI are helping you to improve your business day by day. Everything is driven based on data. So if you don't have data, you cannot implement all these systems. So with the data only, you can improvise your business. You can improvise all the teams, all the services here. Okay, so let us move. So far we have seen how data is useful in different places. Now we'll see data challenges. So what are the challenges we have with the data? So biggest challenge is volume of data. When volume of data increases, because we have a larger users and we have a lot of application in enterprise scenario, your volume of data is going to be huge. When volume of data is huge, then your application tends to behave differently. Performance will go down. You will have uh, performance issues, slower pipelines, data issues, memory issues, cluster issue. So when volume of data increases, you need to, your environment should be able to handle it. So data challenges, volume is the first one. So when we are choosing a framework, when you are designing a ETL system, you should consider about all the data challenges. Okay, so when I'm going to design a ETL system or when I'm going to design a data pipeline, I should consider about all these data challenges. So next is velocity, right? How fast you can process the data. So the data is coming. So let us take in a banking, you are trying to identify a fraudulent activity of customer. So you should identify in next 5 minutes or next 2 minutes, right? Whenever the fraudulent activity happens, you should be able to identify it immediately. You cannot do it after like 1 hour after one day, right? So that is what velocity is. Velocity is how soon you can process the data, and from that you can identify value or identify like the fraudulent activity in the data. So velocity is more about how soon you can process the data. Streaming system. So like when you are handling data challenges, velocity is another one which is important, which is like how fast you can process the data and identify the difference in the data or identify the fraudulent activity or identify the invalid records. Like that, velocity plays an important. Next is variety. Variety is you have different type of data in organizations. You have CSV data, JSON data, you have table format data, you have media files, audio files, image files, PDF files, like you have varieties of data. So my big data system, my data pipeline should be able to handle different type of data. So like in machine learning or AI use cases, we use images, right? We store images, we store PDF files when we are doing like LLMs and then chat analysis, we may process the data from PDF. So you should store PDF data and then you should extract data from PDF. So like that, you should able to handle different variety of data. Okay. So that is what again the other problem is the data challenge, variety of data. And veracity is how soon, how accurate your data is. We are collecting data from different systems. We are collecting from ERP, we are collecting from legacy systems, we are collecting from OLAP, OLTP systems. So when you are collecting it, the data, how accuracy the data is, whether it has null values or it is having some invalid values. So you should able to skip that or do error handling that and then identify the valid data and maintain the accuracy of data. That is what veracity is. So your data framework, ETL system should be able to identify the accuracy of data. And the other thing is like value, how we can get value out of data, and how you can govern the data better, identify the quality of data and govern it better. And like other factors are variability, venue, vocabulary. So all these things are data challenges, right? So all these things are data challenges. So like in machine learning use cases, dynamically the data will change, dynamically the schema will change. That is what variability is. And when we are working on uh, different data is coming in from different places, different when data is coming from different heterogeneous systems, the data can change it. That is what venue is. And vocabulary and vagueness are different format of data. It's nothing but different challenges we face it in data, and we choose a framework which can solve all these problems. So we choose a framework, for example, to handle large volume of data, to solve variety of data. We use a Spark, right? We use ETL using Spark. So it can handle large volume of data. It can process different type of data. It can handle error handling, quality of data. We do data quality checks. We handle accuracy of data. So like all these challenges, we try to solve in the big data systems by choosing right framework and right kind of ETL systems. Okay. So next we'll move on. So what are the types of data we have? We have structured data, unstructured data, semi-structured data, machine learning data, logging data, geospatial data, open source data. So we have different types of data. So you should be able to handle different kind of data. Okay. So next is enterprise data platform. Okay. So in enterprise, the data platform will look like this. As we discussed, the data may be in different format. It can be JSON format. It can be Parquet. It can be logs. It can be API or zip files from FTP or unstructured data, PDF files. So the data can come from different formats from source system. So using batch process, we store the data into data storage layer here. The storage layer, it can be data lake, can be data warehouse, it can be lakehouse architecture. Okay, so these are the data layer. We have a storage layer where we store the data, and we store raw data. We store enriched data. So we store the raw data which is coming from source, that we do ETL and transform it and convert that into enriched data. That is transformed data. And that transformed data is used by consumers. So consumers can be data science team, can be BA teams. So different teams, right? They are going to use the data. So this is how a enterprise data platform looks like. So in the enterprise data platform, you may handle batch processing or streaming of data, and we use different data component, right? We use data lake, we use data warehouse, we use lakehouse architecture. So we are going to see all this thing in detail. We are going to see ingestion, batch processing, how it can be done, how you can use data lake, how you can use data warehouse, and how lakehouse architecture can be used, and how governance can be done better, and how catalogs are created. So we are going to see in depth on each of this area. Okay, so to understand what are the data types are there. Okay, first let us start. What are the data types? So I think most of you would have used database before. Database is a structured data I can store my structured data into database. It's a table format of data. It has a schema. And you can see here, your database, it's an operational database. It's part of OLTP system. Okay. So what is OLTP? So let us see that. So your database can be MySQL, Postgres, SQL Server, Oracle, or any other relational database, right? RDBMS system. So this RDBMS system. So let me show quickly, yeah, RDBMS system. So I'm going to my local. I have installed DB Viewer. DB Viewer is a client too. I'll tell you how to install it and how to configure this. I'll tell later. For now, I'm going to show it. I have MySQL server. So I'm going to connect to MySQL and show the table data, structured data. So using DBviewer, I can connect to any of database. Like I can connect to, you can see I can connect to SQL Server, MySQL, Oracle, Postgres, any of the server. It can be on premises or it can be on cloud. So I can connect it and see the data. So I have MySQL running on the cloud. So you can see I have databases. So we'll go to retail sales and I have some tables here. You can see I have customer, product, I have tables here. So this tables has some data. So it's a schema. So you can see the schema of the table. So go to properties, DDLs. So this is the schema where we have some columns of text, some column of integer, some columns are decimal. Like that we have different type of column. So and then data, if you see, this is how the data looks. So in RDBMS, you have the data which is in a structured form, and this data has high consistency, and like the relational here relational datas, the advantages, it has high consistency and accuracy, but the problem is you cannot store large volume of data. So the problem with your RDBM is it doesn't have scalability. Okay, that means I cannot store a huge volume of data. Okay, your database, you can store 1 year of data or 6 months of data, right? So you can store only the recent used data, but you cannot store historical data. So enterprise are operating for 10 years and their data is huge. I cannot store all the data. If I store, my performance of RDBMS will go down. Okay, that is why we don't store all the historical data in RDBMS. So, this is called OLTP. It's online transaction processing. So we have only transaction data, which is like 1 year or 6 months of data. So what is this data? If you are working for banking or if you are working for retail, so let us say you, for two example, let us say, so you are working for banking or you are working for retail. So the core business of banking, right? What is the core business of banking? So you have some internet banking applications, or you are having some applications where customers can pay money or pay to other clients. So where it's more of online applications on the banking, right? So you buy something, sell something, or you transfer from one account to other account. So when you do all this, the data is saved on the RDBMS. So when you are doing transactions, when you are doing payments, all this thing, your data is getting saved on RDBMS here. And that data, it's a recent data, 6 month data or 1 year data. So 1 year data is stored in RDBMS. So here, this is called operational data. So what about the old data, historical data? It's not stored here. Where it is stored, historical data are stored in data warehouse, or data lake. Okay, so your data warehouse and data lake can scale up easily. Both can scale up to large volume of data. So I can store 10 years of data, 20 years of data, any volume of data, huge volume of data, I can store it in data warehouse or data lake. Okay, so my 6 month of data, the transaction data will be here, and all the history data and like latest data will be there in the system. Okay, so if I'm going to use analytics, I will use data warehouse and data lake for doing analytics. So I'll use analytics. I will do it on this system. I'm going to extract from RDBMS and then I'm going to push it to data warehouse or data lake. And from there, I'm going to do analytics. Same applies to ML, same applies to AI. Because for all this system, you need historical data. So if I need to do analytics, I need historical data. If I need to do ML or AI, I need not only the current data, right? I need historical data. Okay, then only I can do all these operations. So we are going to use data warehouse or and the data lake for getting the data. Same applies to retail. So retail, let us say e-commerce company, they have application where you can buy a product. So in RDBMS, there will be datas. So there will be like datas about products. So recent products, customer. So there will be data about your customer, order details, uh, delivery details, when delivery. So all these informations are stored in RDBMS. All this thing are 6 month data or 1 year data. And what about historical data? Historical data are stored in data warehouse and data lake. Okay, so any enterprise, they are going to use OLTP and OLAP. Okay, so if you see now, so your database where we are storing structured data, it has a predefined schema and use case, it's a operational application, OLTP system. Okay, whereas data warehouse system, it's a structured data. So again, in data warehouse, we store only structured data. If it is an unstructured or semi-structured, we are going to use data lake. Okay, so data warehouse, we store structured data. But here, you can store historical data, current data. So we use it for business intelligence. We use it for machine learning AI. So we can use this organization-wide data. So we have one more thing, which is data mart. So what is data mart? So department specific data is called data mart. So in organization, there can be multiple departments, like there can be sales, there can be finance, HR, like marketing, like that, different departments. So department specific data is called data mart. So organization wide data store is called data warehouse. Department specific data is called data mart. So again, here using data marts also, you can write, you can derive analytics. You can, for example, from sales data mart, you do sales analytics. From sales data mart, I do sales machine learning or sales AI functionality. Okay, so if you want to do organization wise activity, you'll use data warehouse. If you want to do department wise business applications, then you will go for data marts. Okay, so in organizations, there will be data warehouse, there will be data marts and data lake. So if you see here, this is how in organizations, your data warehouse will look like. You can see there is marketing, sales, ERP, SCM. So different data, right? So the data comes into your data warehouse using staging area. And from data warehouse, there can be multiple data marts. The data marts are can be like finance, can be sales, can be HR, like that. There can be multiple data marts. Okay, so data marts are specific to business group and data warehouse are organization wide data. That is the difference. Okay, fine. So we have seen so far what is database, what is data warehouse, what is data mart, and then data lake. Any question on this so far? So if you have any questions, you can always put it in the chat, or you can ask me in the call. End of the sessions, you can ask me in the call. Okay. So far we have seen all we are seeing about the basic, right? So far we did not get into AWS services. We did not get into data lake or data mart. We are just seeing high level how a data architecture would look like and what are the data storage layer are there. And that is what we are focusing so far. We are seeing about different storage layers in a data platform. Okay, so we have seen first how a data platform looks like. In data platform, we are focusing on the storage layer. Okay, storage layer, we have data lake, data warehouse, and lakehouse architecture. So that is what we have started discussion. So we have source, we have target. Source is the enterprise upstream systems. The target is the consumers. The consumers are the data science, business teams, analytics teams. So, and in data layer, we have storage layer. In storage layer, we have data lake, data warehouse, lakehouse architecture. So far we have started on data lake and then data warehouse. That is where we have started. So where is the one question here? Where is the data mart in storage layer? So data marts are nothing but data warehouse, right? So it's a business specific data warehouse. It's nothing but it's similar to data warehouse, but it's specific to a business group. That is why it's not specified separately. It's part of your data warehouse. Okay, so difference between your data warehouse and data mart is nothing big. Your data warehouse is organization wide data. So it collects data from various business groups and it has the organization wide data. Whereas data mart has specific to business group. But both are data warehouse. Okay, both are data warehouse where it has a staging layer, where it has the dimension models, where you are going to create tables and you are going to do dimension modeling on that and create the tables and the data set. Okay, fine. So let us move on. So next is, so in the modern data architecture,
What is the injection? What will do injection?
ingestion, uh, it's like collecting the data, right? How you can collect the data. So you have source systems. From source systems, how I can collect the data and push it to your store onto data layer. So I can do batch processing, I can do streaming. So in batch processing, we pull the data. So the data it's coming in from uh, CSV files into your data lake. You are taking the data and processing it and storing it. Or the data, you are reading it from database. I have a database, I'm reading the data and pushing it to data lake. So ingestion is nothing but collecting the data from various sources. So the way you can do it in batch processing or streaming. That is a two way of ingestion. Or you can do event driven ingestion also. Okay, so other question is how data lake is different from customer data platform. So in my firm, the migration plan is from on-premises SQL Server. Okay, so there is one more question. It's is about collecting the data into data lake. So they have a data platform and collecting the data into data lake. I'll explain this later. I'm going to get into the topic. So I'll be covering your question here. So we can wait for a few minutes because when I'm going to cover a data lake, your question will be covered. Okay. Okay. So next thing is in the modern data architecture, you can see the data lake plays a central role. Okay, why data lake plays a central role? Because data lake is cheaper and data lake is used heavily in organizations. Okay, so what is data lake? So in AWS, what is our data lake? Let us go to AWS quickly. I'm going into AWS. So I'm logging into AWS to my console. And in AWS, S3, AWS S3 is the data lake. Okay, so as name suggests, you can put large amount of data into data lake. So I can create a bucket and I can put in data into the folders. It can be semi-structured data, structured data, unstructured data. Any type of data I can put it. And the cost of your data lake is very cheaper. For organization, they use data lake for different activity. What are activity? Let us see that. So you can see here. So like we are going to see from simple activity to complex one. Okay, so uh, in enterprise, we have different type of data: structured data, CSV Parquet files, or semi-structured data, JSON, XML, Avro, or unstructured data, right? So images, video, PDF, files, logs. So you store all the data into data lake. So you are collecting data from various sources and maintaining it in a single place. And your data lake can scale. I can maintain 10 years of data, 20 years of data, because your data lake is cheaper. And for organizations, that is a central place where you can maintain all the single source of truth. Okay, so it can store all the data. So it's a centralized store for all type of data. Next is when you are working with different systems, right? When you are working with database, when you're working with APIs or streaming, your data lake acts as a staging layer. Okay, so you have a database which is an on-premises database. So from on-premises, I can push the data into data lake. Once the data comes into data lake, then I can easily transform it, or I can convert into another form, or take a backup and then maintain it in the different form, or I can move the data into cloud database. So I can uh, like replicate the same data which is there in on premises in the cloud. So I can create a replica of the database on the cloud. So first purpose is you need to move it to data lake, then only you can do it. So you can use DMS, you can use AWS as a service called DMS, data migration service, or you can use Glue or any custom pipeline. So it's nothing but you are migrating your data from on-premises, or your database is there in the cloud, one region, it's there in one region and you want to move it to another region. In that time, you first move into stage environment, that is your data lake. So you move into data lake, then you move it into your replica database. So that is how we do it. So you for maintaining the replica, your database plays as a staging layer. Okay, so it's for database, right? Again, if you have APIs, so I have a REST APIs, I want to store the data. So I can store it into data lake. I can schedule it and then store it. So I can collect the data and bring it to the staging layer. Then I can do transformation. So your data lake always helps you to collect the data from various sources. It can be API, it can be streaming, or it can be legacy application, third-party applications. So you can collect the data and your data lake plays a staging part. And then for ETL processing, you bring the data into staging layer and you can transform it. I can build silver gold layer. That means I can do processing. I can do ETL activity. I can convert the data from raw form into structured form or aggregated form, and then maintain the data in the data lake itself. So you can do ETL or ELT, right? So you can do both ETL or ELT on the data which is there in data lake. So for that you can use Glue, EMR, Databricks. You can use Spark, or if it is a simple, if you have a data is small, right? Smaller data set, you can use Lambda. If the data size is huge, you will go for Glue, EMR, or Databricks. If the data size is large, if data size is small, you will go for Lambda. And you can build ETL or ELT on the data lake. So far we have seen everything on the data lake, right? So the operation is done on using data lake. Other than that, Lakehouse architecture. So you want to build a Lakehouse architecture. That means on data lake, I want to do updates. I want to do deletes. I want to implement asset transaction property. Like a database, I want to convert my data lake in like a data warehouse. For that, we use Lakehouse architecture. By using Iceberg, using Delta Lake, this everything happens on data lake. So I can store the data into data lake, but using Iceberg, I can implement asset transactions. I can implement time travel, versioning you can maintain. I can do updates, delete on the data lake. Okay, like that. Next is like a machine learning. When you are going to work on machine learning or AI use cases, when you are working on machine learning or AI, the first step is training the data set. Training we do, and then once training is completed, serving is the next part. In machine learning operations, we do two kind of operations. We call it as model development and then model serving. Okay, so model serving, it's a final part. Okay, model development. For model development, this is a mathematical model, right? So for this model, mathematical model, you may use TensorFlow or you may use Keras, like different Python, right? PyTorch, MLib, like different Python framework. So when you are going to use different Python framework, you are writing a mathematical model, but data, you are going to use historical data here. So the historical data is going to come and you are going to use data lake for storing all this data. So you're going to collect data from various sources and historical data you are going to store it in data lake. So when you are going to do model development for training the data sets, you need data lake. Without data lake, you cannot do training of data sets. And once the data is trained, then the model is used for serving. So this is a live, right? This model becomes live, and this model you can use it in the live. So for training, you need data lake, and for model serving, this mathematical model is converted into a binary file. It's converted into binary file, and that binary file is again placed in S3 on the data lake. So for the model serving, we keep the binary file in S3 so that we can maintain multiple versions, and this binary file can be shared across different business group. So the model implemented can be shared with different business group. Okay, so for machine learning use case, we use data lake heavily for training data set, for maintaining multiple versions of model, for sharing with different teams, we use. Okay, so for analytics and reporting, we store the data into data lake, and after storing the data, we use like Athena or Snowflake or Redshift to do analytical queries, and using dashboards like tools like Tableau, Power BI, we build dashboards, and for analytical uses, the data is stored in data lake or the data is stored in data warehouse, and then we perform the analytics. So other than that, for data storage, that means I want to take a backup of data for compliance, for audit, for backup of data, for compliance, for disaster recovery. You maintain data in data lake, and for sharing the data with different teams or sharing with the different business group within the organization or with the other organization. So for example, there is a data products are nothing but for our organization, they have using weather data, right? So normally weather data, a third party company is maintaining weather data and they are sharing with all the organization. It's not that one company, the same company is getting the weather data, right? Or like other data like credit card like informations or fraudulent informations. For that, we have services where you can collect data from different products. So that all called data products. So for that also, you can use data lake. So other than that, for event-driven pipeline, we use data lake, and for logging, for auditing, we use data lake. Okay, these are the basic use case, right? Other than this, there are advanced use cases. Advanced use case like when you are going to implement multi-tenant platform, data as a service. So for enterprise, they want to implement Lakos and they want to share the data across multiple business group, and they want to maintain data as a service. For that, they use data lake. For real-time streaming, they use data lake. And for understanding the lineage, they use data lake. And other than that, uh, if you are going to store unstructured data like PDF, image, audio, and you are going to do NLP, or you are going to do language models like using AI, right? For that, you use data lake. Like that, there are a lot of use cases. You can see other than that, CDC, right? CDC is change data capture. On database, you are doing CDC. Like this, for all these use cases, a lot of your use cases are machine learning models, generative AI, LLMs. Like this, all these use cases, data lake is used heavily. So that is why first we are going to start with data lake. Okay, so we are going to focus more into data lake. Then we will go into using relational database, using data warehouse. That is the next thing we are going to do. First thing, we are going to use data lake. Okay, so we are going to create buckets. So we are going to create buckets, and we are going to put data into data lake, CSV files, JSON files, different type of files, compressed files, and partition data. So as a data engineer, we should be very comfortable using data lake. So in organizations, data lake is heavily used for lot of purpose, right? I showed here the lot of use cases, right? So if you are not sure about data warehouse, that is fine. In some organization, they may not be using data warehouse, or they may not be using machine learning at all, but they will be using data lake. So you should be very clear on data lake and database. Database is very important and data lake is very important. Okay, uh, so we are going to start with data lake, like reading data into data lake, different format of data, writing data into data lake, different type of data. So all this thing we are going to cover. Okay, so if you see, these are the services we are going to focus. So in the next coming classes, we will be starting on S3, and we will be using glue and then S3, and we will go into RDS, DynamoDB. So for ingestion of data, we are going into S3 and RDS, DynamoDB, and glue. So that is what we are going to start. Okay, so one question here: can we consider your Google Drive as a data lake? Yeah, little bit, but Google Drive, there is yeah, constraint, right? So you have a limited usage, right? So there is a limitation, right? Google Cloud is not cheaper, right? It's charged. So after some point, you have to pay money for Google Cloud. It's not that cheap. Google Drive is not cheap, right? Whereas your data lake is cheaper. Data lake, the charges for terabytes of data, you pay less money. So you cannot compare your Google Drive, because Google Drive is costly. Even though you can use it free for only like 15 GB of data. After that, you need to upgrade for a higher version where you have to pay money. But whereas if you see data lake, for terabytes of data, you are paying very less money. For enterprise, S3 is like very cheap. So they use heavily. They store a lot of data in S3. Okay, so uh, as I said, data lake plays a major role for uh, any data which is coming in from source. They collect it and put it to data lake. Okay, why they do it? Because we are building a data platform. In data platform, we are going to maintain the raw form. Why is that? Let us come back and then we'll get into the next. So in organizations, so think that I have 200 source systems. I have 200 plus source system. That can be ERP, SAP, or it can be a database, right? Relational database like MySQL or SQL Server or Salesforce. So I have 200 plus sources here. So I have 200 plus sources. So I'm going to collect this data and bring it into data lake. So I'm going to bring it into data lake, and in data lake, I'm going to maintain raw data, transformed data, or you can say this processed data. And then one more is I think I got lost. Is my voice clear? Okay, fine. If my voice is clear, then fine. So you can see here, we are collecting data from various systems, and that data, we are maintaining it in raw. So that this raw is called bronze layer or staging layer, right? So why we do it? Because I need to know the lineage here. So from source, I'm collecting the data, bring it here. So that version we can say 1.0, and I'm transforming it, and this version we can say 2.0. And I'm aggregating here, this is 3.0. So the same data is converted into three versions here. And at last, I am using this data. When using it, there is a problem in this data. There is a data quality problem, and we want to see where the problem happened. So for that, for identifying that, lineage will help. That means whether it happened here in the aggregation layer, or it happened here in the transformation layer, or it happened in the raw layer itself. That means from the source did the issue happen. So if it happened here in the aggregation process, I can fix it here. Then it is a problem with the data engineering team, we have to fix it. If it problem happened here, while doing transformations, the issue got in, and I can fix it here. If it happened in the raw layer, then it's a problem with the source itself. So I inform particular team. So that is the reason why we maintain multiple copies of data. Okay, and this in the data lake we do this, right? So we maintain this in data. For 200 plus sources we do it, and this helps for auditing, for error handling, for achieving high quality of data. Okay, this we do it in all the organizations. This is how you improve your data quality from the raw form of data. You are bringing high quality of data. Okay, this is how you can improve quality of data. So for this, we use data lake, and we are collecting the data and storing the data as it is. Okay, so in the raw layer, we are collecting the data and storing it as it is. Okay, fine. So data lake is heavily used, and S3 is the data lake where we are going to use heavily. Okay, fine. So now what we are going to do next section is we are going to start with S3. We are going to start with IM, and then we are going to do some ETL, simple ETLs, write some Spark code. For that, we have to set up the environment. Okay, so we need to set up the local environment first. So you have to create first AWS trial account. So AWS trial account. So if you see AWS free trial, because from next class, we are going to start with technical implementation, right? So when we are going to implement, you can try it on your account. So you have to create your AWS account. So you can create your trial account. So when creating free tier account, it may ask you for some bank accounts or credit card details, right? So when you create this, it will ask for email ID, address, all this thing. It will ask for bank account. So that is for validating your account details. They will take $1 and then they will back. So that means like $1 and they'll give it to back. And monthly, the billing will be monthly, and you are going to pay. Okay, from AWS, you can see here. If you go to Cost Explorer, so this is Cost Explorer, where we will get monthly bills here. So here we are going to pay manually. Okay, so they are not going to automatically deduct from your account, right? So even though you are registering with your bank account, but they are not going to deduct automatically. We are going to pay bill monthly. The payment we are going to do monthly here. So only for validation, they are going to ask for your accounts and then they will be validating. So first is you have to create your free tier account, and then we need some installation to be done. Okay, what are the installation? In your local environment, we have to install few softwares. So I'll say what are the softwares are required. Okay, so you can see here. So in a local setup, you need Visual Studio Code. You need to install Visual Studio Code. So I'll show my environment. You can see Visual Studio Code. So Visual Studio Code is for developing Python, for writing code on Visual Studio using Python. So for that, we have to install Visual Studio. So I'm going to send today this PDF. You can download this PDF and you can download the exe and install it. First, you have to install Visual Studio, then AWS CLI. So why AWS CLI? Because after installing the Visual Studio Code, we are going to like configure your AWS account on local. So that from my local account, so from your Visual Studio, I can create any AWS services. So using both of three scripts, I can create RDS, I can create S3, I can create Glue, I can create DynamoDB. So everything from your local ID. Okay, so that is why we are creating AWS CLI. So we will create a AWS account and we will configure that user in your local. So that from your local Visual Studio Code, you can create AWS services. So you have to configure your AWS CLI. So here, if you see the installation here, you see this is more of installation. We have not done any configuration. In the next class, we are going to do the configuration. I'll show you how to do the configuration for CLI, for Docker, everything I'm going to show in the next class. So in the first class, you are going to do installation on your environment. That means you will install all the required software. So we need Visual Studio, CLI. You need to install Python in your local. So, and then you can verify it. Right? So how we can verify? In the Visual Studio Code, you can go, I'll close all this thing. Can open terminal and verify if Python is installed. So you can see Python is installed, and you can verify AWS CLI is installed. So you can see Python is installed in my machine. AWS CLI is installed. And other than that, you need Docker desktop because we are going to run Glue on your Docker. Okay, so we need to install Docker. So you can see Docker PS. So you can see Docker is there. And you can see Docker desktop is installed in my local. Okay, so all this thing, you can follow the document and then install it one by one. So you can install all this thing, and then next is DB viewer, right? So you can install DB viewer in your local. So you can see the exe here. You can install that local. So DB viewer is to client to connect to your database, to visualize your data, to check your validate your data. We are going to use DB viewer. Okay, so this is local development setup. You have to do it on your local machine. To download this software and install it on your local. So in the next class, we are going to configure AWS account, and then we are going to start working on AWS services in the next class. So as I said, we are going to install Docker on it, right? So why Docker? Why we are going to use Docker? Because we are going to start glue on your local. So here, why glue? We are going to use Spark. Spark for ETL. We are going to write data pipelines using Spark. So for Spark, uh, we can use glue environment. So this glue environment, you can use it. We can develop there, but the billing is costly here. It's not free, it's billable, and development is not easy here. Developing directly on glue is not easy because it's a more of text editor here. So it's not easy to develop and debug. It's very tough to do it here on this environment. That is why we are going to set up Docker on our local, and we are going to use Jupyter Notebook. So once you set up Docker, you will have Jupyter Notebook. In the Jupyter Notebook, you can see we can write Spark code. I can read data from S3. I can write it to S3. I can read and write data from data lake. I can access RDS. I can access database. So all the development, you can do it on Jupyter Notebook. So this is free and it's easier to debug, easier to work. So it makes your development easier. So once you are comfortable with this, then we will go into glue environment and we will work on glue environment. Okay, that is how we are going to do. Okay, so any question from anyone on the local environment setup, on local development setup?
I have one doubt,
Yeah.
about AWS. So
Okay.
nowadays, every company asking AWS certification.
Yeah.
So if you this course, if you complete it, when I expert for AWS, so can I write the exam like that? Is it possible
Uh,
that
so,
I will get that knowledge or
so AWS has a certification, AWS
okay?
Data Engineer Associate.
Okay.
Uh, that has, if you see the core syllabus of that, right? It covers like hundreds of services. In AWS, you need to focus on 100 services for completing the certification. That is very tough to do. But if you see as a data engineer, we will 10 or 12 services. Okay, for certification, you are going to go through lot of unwanted services also. So for certification, we are covering the main services are going to be 10 services, right? But we are covering the 10 services. Other than that, you have to do self-study for other services. That services are not going to be used in the real world, but for certification, you have to prepare on the services. But we are going to focus on the main services which are used in the company. So in
Okay.
this course, we are focusing on more of the implementation, right? In the how real world projects are implemented and what are the major services implemented, right? But if you take for certification wise, AWS is focusing on all the services and they are concentrating on like 100 plus services there, which are not needed for us. As a data engineer, we don't use all the services. We use only few 10 or 15 services. So in this course, we
Okay.
are concentrating on 10 or 15 services. Other than that, you have to prepare for other services.
Okay, fine. And can you suggest me any one course for AWS for certificate purpose? So, because of my friend is
So
trying,
I,
company is
I, I
asking
would recommend
certificate.
you to do Databricks certification instead of doing AWS certification. Okay, so
Okay.
you can do Databricks Associate Engineer certification. That is, it's more of Spark and it's more of data engineer certification. Okay, so if
Okay.
you
Okay.
see AWS certification, they focus on other aspect also, more into AWS cloud aspect, right? It's not specific to data engineer. But if you see Databricks certification, it's more of data engineer certification, where they
Oh.
cover only on data engineer aspects.
Okay. Yeah. Thank you. Yes.
Can we, the other question, can we use Collab instead of Jupyter Notebook, local Jupyter Notebook? You can use Collab. If your problem with Collab is you need to install Spark there and the resources are not sure how many resources like CPUs are there, how many memory is there in the collab. Okay, so when you are running Spark, right, you are going to run it in standard fashion. Example, I can show it here. So here, I'll create quickly. So I'll go to my local. I'm creating one new notebook. I'm creating a new notebook. So I'm going to create Spark session. So I'll create Spark session. So I can specify in my local, if I go to Docker, so I'm seeing my Docker. You can see totally I have 12 CPUs. In my local, I have 12 CPU and 8 GB of RAM. So this is my resource in my local. So I can run 12 parallel tasks. Okay, so I in my local as I have 12 CPU, I can run 12 parallel tasks. So I can specify I don't want to use 12, right? Because my system needs some CPU. So I'm giving 10. So I'm going to say create 10 parallel tasks and do parallel computation. That is how you can efficiently use in your local. But whereas if you're using Collab, they are not going to give a lot of CPU. They may give you one CPU or two CPU max. So you cannot do parallelization there. Whereas in your local, you may have more CPU, so you can do parallelization. So you can try to do parallel operations here. And we have more RAM memory, so you can process large amount of data. So I can take 100 GB of data and process it in your local. Okay, that is the difference between collab and local. Okay, fine. So any questions from anyone so far on the environment setup? So for other question, AWS Solution Architect Certification, how much this course is? So this course, we cover all the major AWS services, right, for specific to data engineering. And we cover a lot of design aspect. For designing a enterprise system, we are covering that. So this course is going to help you for the solution architect exam. The point I'm saying is, other than this course, you may have to prepare on few of the other services. We are covering the major items here. We are covering the major one which are used in the organizations. Other than that, there are few chapters, few models which maybe we are not using frequently in enterprise, but for certification specific, you have to prepare. That is what I'm saying. But we are covering major ones like S3, we are covering RDA, we are covering Redshift, we are covering about lambda step function. These are the main focus which regularly used in organization. Other than that, for solution architect, you have to prepare on SageMaker. SageMaker is a data science tool, but for certification they ask you. And as a data engineer, I don't use SageMaker. That is used by data science team. It's used by different team. I don't use SageMaker. But for certification, I have to prepare on SageMaker. Why is SageMaker? I need to learn that. Like that, some services, right? As a data engineer, we don't use it, but certification purpose, you need to learn that. That is what I'm saying. But we are covering all the data engineering specific services here. Other than that, you may have to learn few of the service specific solution architect or data engineering associate exams for AWS. So other question here, transformation will be learning locally in AWS services or taking it to live. So we are going to do local development. Once local development is done, this code can be deployed on the cloud. Okay, so in local, we have minimal resource, right? That means I have 8 CPU and I have only 8 GB of RAM. In the cloud, so if I go to cloud, if I go to Glue, I'll go to cloud. I'm going to specific region, Mumbai. That's why I use it. And if I go to ETL jobs here I can scale up easily. So you can see I am using GX. It's a 4 CPU, 16 GB RAM. So that I can say use 20 mission or 200 mission. You can scale it up easily. So we will learn, we will do local development, we will deploy it in Glue,
and we will run it on the glue also. So first project, when you are completing the first project, we will be running the workflow. So you can see the workflow manager on the glue here. Okay, the first project, this is what we are doing. We are building a ETL pipeline, batch processing pipeline, using the workflow manager here in glue. Okay, so here we are doing orchestration using the Google Workflow Manager, and we are triggering multiple jobs here. We are triggering 4 jobs, and crawler we are triggering so that we can create catalog. We can see all the data in the catalog. Okay, so other thing is, why Jupyter Notebook here? Okay, so we use Visual Studio. So we are using Visual Studio. We use Jupyter Notebook, and we have cloud, right? So we have multiple environments, right? Why? Because in enterprise also we use like this. Because to fasten development, if I directly develop in cloud, my development and my debugging is tough. Because here, if you see here, if I do small change and run it, for starting this, it will take a lot of time. And for debugging, error handling, it's very tough to do. So like modifying the change or converting this into maintainable code is very difficult to do it. But if I'm going to do it in Jupyter Notebook, I can easily do it, and I can fix the code easily, debug the errors and fix the issue. So that is why we are doing it in the Jupyter Notebook. And other purposes, once you have done it in Jupyter Notebook, the same code, you can download it. So you can download the same code, you can download the Python files, and then you can deploy it in Databricks. The same code can be deployed in Databricks. Same code can be deployed in Microsoft Fabric. Okay, because there also it's a Spark cluster environment. So you can develop the code in Jupyter Notebook, and you can deploy it in multiple places, right? You can deploy it in Glue. That means you can take the code, deploy it in Glue for AWS services. And tomorrow, your company has migrated from AWS, they have migrated into Azure, or they have migrated into Databricks. So they are going to use Databricks. We can use the same code in Databricks or use the same code in Microsoft Fabric. As we are learning Spark, it's easier for us to migrate to different platforms. That's why Spark is very powerful. It's used across all the cloud and all the platforms. I'll cover a little bit on cost optimization, how you can efficiently optimize your cost, especially cluster, right? So how many cluster, that means if you are using 1 TB of data, how many missions you need? And your SLA, you have a tight SLA. So I'll show that 1 TB analysis. So let me go into glue section. Okay, this is the 1 TB analysis. That means if you have 1 TB of data, so my expectation is in the organization, I have 1 TB of data, and my SLA is to process within 5 minutes. My workflow should complete within 5 minutes. How many missions required? 70 missions are required. If I have a less SLA, I can take ETA, SLA for completing the ETL 1 hour. Then I can use 6 or 7 missions. Okay, so this I'll explain in depth how you can do cost optimization, how many missions are required for processing data, and in AWS, how you can see cost utilization, and how you can fine tune it. All this thing we'll discuss. Okay, so any questions from anyone? The expectation is for the next class, right? So you are supposed to set up the local development environment where we need Visual Studio, CLI, AWS CLI, Python, and Docker desktop installed in your local. So once it is done, then what we are going to do is we are going to start setting up our local environment. That means I'll show you how to start the Jupyter notebook and how to start developing ETL data pipelines on the notebooks. That is what we are going to start. So first step is we are going to use data lake. Okay, so you can see in the uh, fourth session, we are going to start with data lake straight away. We are going to read data, write data into data lake. So we are going to start with data lake. So we are going to use different type of data, bring the data from database, uh, bring the data from flat files like that. We are going to use data lake and different format of data. Okay, fine. So any questions from anyone so far on the introduction here? So here we are going to build a data platform. For the data platform, we are going to concentrate on batch processing, streaming pipeline, event-driven pipeline. And initially, we are starting with the storage layer. So we're going to start with the storage layer. We are going to build ETL pipeline. Uh, so ETL basic like using glue. Okay, so we are going to start glue and data lake. So we are not start data or lakehouse architecture. So we are going to start with data lake and glue ETL pipeline. For that, we need the local environment setup. Okay, that is what we have to start it. And then we need source, right? So source is going to be RDS, DynamoDB, and S3. Okay, so initially we are going to read data from RDS, we are going to read data from DynamoDB, and we are going to read data from S3. So this will be our source system. So that is the first project. In the first project, we use all the system as a source, and we are going to concentrate on data lake here. We are going to use data lake heavily for the first project. So other thing question is for your personal laptop, what is the minimal configuration? So you should need at least 8 GB of RAM because Spark needs a lot of RAM memory and it needs at least 4 CPU or 8 or 12 CPU. Okay, so you can have 4 CPU, that is also fine because with 2 CPU you can do 2 parallel processing. If you have 8 CPU, that is fine. So you can do 6 parallel processing or 5 parallel processing. If you have 8 GB, it is fine. 8 GB or even 4 GB is fine. The thing is, you can do simple operations. But when volume of data increases, your performance will be slow. That is the problem. It's not that your Spark is going to fail. Spark will continue to run. The job will be slower. That is the difference. It's going to use with 2 CPU, 2 GB of RAM. Your Spark will run for longer duration. It's not that it's going to run slower. You can use i5 or i6 or i7. That is fine. Any i5 is also fine. So laptop configuration i5 is also fine. That is a minimal thing. If you have i6, i7, that is also fine. So you may get access to the courses, right? So you are going to get access to the courses. So here we are going to put a recorded video and then we are going to upload the PDF files here. Okay, so Bhumika will be giving access. So from today we have shared Zoom link, right? In future, we'll be sharing the Graphy link. So recording will be there here itself. Initially, few classes will be on Zoom and slowly we will move into Graphy. So all the recordings will be here and then the source files will be placed here. But for today, I'm going to send the PDF file to the WhatsApp itself. So you can download this PDF and start working on your local environment. The other thing is, so we are going to start basic sections, right? We are going to start from next session. We are going to start first is we are going to start with IAM. We are going to create a user, and for that user, we are going to create a CLA account, and that CLA account we will use it in locally. So we'll be seeing IAM, we'll be seeing S3, we'll be seeing EC2. So we'll start on the core services. Okay, so we'll start on the core services. Then we will start with ETL. We will be starting with RDS, DynamoDB. Like that, we'll start with basic services. So for the first 10 days, we will be focusing more on S3, uh, Glue ETL, Spark. That is our focus will be. And RDS, DynamoDB. So for the first project, we focusing on so we will concentrate on data lake scenarios. We will be more focused on handling different format of data, CSV, JSON data, and then Parquet data. And we will get into ETL. We will get into partitioning concepts, handling large volume of data. So this is where we'll be focusing, building a data pipeline using Glue. That is what I will be focusing for the first 10 days. Then slowly we will move into other sections like advanced sections on the orchestration, Lambda, error handling. We'll go into the next sections. Okay, fine. Any questions from anyone? So if we don't have any questions, we can stop it for today. The expectation is you have to create your free tier account and then you have to set up your local environment so that you can go faster. Otherwise, what will happen is initially, if you don't have AWS account, if you don't have local environment, whatever I am showing it, it's difficult for you to implement it. Okay, because I'll be showing a lot of things. The basic ones I'll be going a little bit faster. So the basic one is working on ETL, Spark, working on reading data, writing data, all these sections. We will be completing it in few classes. If you see in initial 4 or 5 classes, we'll be completing all the basic sections. For that, you need to have local environment. You need to have the local setup. So if you don't have that, it's difficult for you to try it out what I teach. Okay, so that is why you set up your local environment. You have your AWS account, then it's easier for you to follow what I'm teaching. Okay, fine. So if you don't have any questions, we'll stop it for today and then we will connect. Next class will be on Tuesday. So Monday, we are not having classes. Normally, the classes will be on Monday, Tuesday, Thursday, and Friday. But this week, we don't have classes on Monday. We'll have classes on Tuesday. So any questions from anyone on the introduction here, on data lake, or on the environment setup? Okay, fine. I think everyone was fine. So we'll stop for today and then we'll connect again on Tuesday. Thanks, everyone.